थोडं कार्यक्रम घेऊ रे रेकॉर्डिंग. ह्या लोकांना थोडस वरी त्या शिक्षक दिनाच्या कार्यक्रमाला हा हा तिथं बरं काय सांग.
त्यांचा मोबाईल
हॅलो भोसले सर. भोसले सर.
सर आवाज येत नाही.
हा आवाज येले का आता?
हा येतो सर.
येतो का नाही?
येतोय सर.
हॅलो
येतोय.
भोसले सर.
येतोय सर आवाज.
हा मग
बोला सर.
चालू करायचं का?
हा 1-2 मिनिट सर. 2 मिनिट.
हॅलो गुड मॉर्निंग काकडे सर. हॅलो.
हा गुड मॉर्निंग सर.
पुन्हा प्रोग्राम
गुड मॉर्निंग. गुड मॉर्निंग. आवाज येतो का सर माझा?
2-3 नाव टाकून टाका. आमचं तेवढं टाका ते राणी काय मग रे.
हा वाघ सर.
नमस्कार नमस्कार.
नमस्कार नमस्कार सर. आज कार्यक्रमाला अचानक हे झालं. काल ते सणामुळे तुम्हाला बोलता आलं नाही.
हा नाही बरोबर.
शिक्षक दिनाच्या तुम्हाला खूप शुभेच्छा.
खूप धन्यवाद सर. धन्यवाद धन्यवाद. तुम्हाला खूप खूप शुभेच्छा.
हा बोला सर. चालू करू का मग विचारा.
करू म्यूट करूया ना.
हो चालेल. YouTube लिंक टाकून द्या ग्रुपवर.
सर बोलू का?
सर
राम सर सुरू करा.
हा
सुरू करा राम सर.
हॅलो.
1 मिनिट सर. सुरू करूया. ओके.
हा हॅलो. गुड मॉर्निंग. गुड मॉर्निंग टू ऑल. मायसेल्फ
व्हेरी
डॉक्टर.
हॅपी अँड प्रॉस्परस सर. हॅलो. हॅलो. आवाज येतोय काकडे?
हा येतो येतो. बोला बोला.
Present over here. I am Dr. Musle, Assistant Department of Physics, and Arts, Commerce, Science College, Kille Dharur. Welcome you all on the occasion of this international workshop on recent trends in nuclear and material science. On behalf of the organizing committee of ACS College, Kille Dharur, and Bhagwan College, Asti, I would like to welcome all the dignitaries, delegates, research scholars participated for this international event throughout the world. I heartily welcome Honorable Dr. B.N. Dole, sir, Professor and Head, Department of Physics, Dr. Babasaheb Ambedkar Marathwada University, who is joining us from the Aurangabad, Maharashtra, who is a keynote speaker for this event. Welcome, respected Dole, sir. I also welcome our other resource person, Honorable Dr. H.O. Tikin, sir, Department of Medical Diagnostic Imaging, University of Sharjah, who is joined us from UAE. I welcome other resource person, our mentor guide, Honorable Dr. Pavina Power ma'am, Professor, Department of Physics, Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. I also welcome Honorable Dr. D.K. Gaikwad, sir, Assistant Professor, Department of Physics, ACS College, Jalgaon. Now not taking too much time, let us have a pleasure to listening open remarks. May I request Honorable Dr. G.K. Kakade, sir, Principal, ACS College, Kille Darur, to deliver the welcome address. Please, Dr. Kakade, sir.
Hello, good morning to all. Am I audible?
Yes, sir.
Am I
Yes.
audible?
Yes, sir.
So once again, good morning to all. Myself, Dr. Gopal Kakade, Principal, Arts, Commerce and Science College, Kille Dharur. At the very outset, I want to express a warm greeting to all the participants and also resource persons on the occasion of birth anniversary of the first teacher, Dr. Sarvapalli Radhakrishnan, on Teachers' Day. So I welcome all for this event and also give the warm wishes on Teachers' Day. At the very again outset, I welcome you for the 2 days virtual international workshop entitled Recent Trends in Nuclear Science and Material Science. I feel honored to be here online with you as a chief organizer of this international workshop linked with Bhagwan Mahavidyalay Asti. We are quite fortunate to have resource persons for this international workshop. Professor B.N. Dole, who is the head of the department, Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, and Professor H.O. Tekin, who is joined from abroad, who is the Professor, Department of Material Diagnostic and Imaging, University of Sharjah. Also, I welcome Professor P.P. Pawar, Madam, who is also a professor of Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, Department of Physics. Also, I welcome Dr. D.K. Gaikwad, who is assistant professor from Arts, Commerce, Science College, Dharangaon, District, Jalgaon. And special welcome to our co-organizers, Principal Dr. D.T. Wag, sir, Principal Bhagwan College, Asti, and also our organizers of this international 2 days international workshop, Dr. L.B. Zadwar, sir, who is the convener of this workshop, Dr. Ram Bhosle, sir, who is the co-convener of this workshop, and all the organizers of Bhagwan College, Asti. Friends, I welcome all the resource persons, delegates, resource scholars from India and abroad for this workshop. On behalf of my honorable office holders, Honorable Prakash Dada Solanke, who is the president of our MSP Mandal Aurangabad, Honorable Satish Bahu Chavan, General Secretary of MSP Mandal, and all the chief CDC members, Honorable Jai Singh Bhaiya Solanke, Honorable Ram Shingare, Honorable Ina Jadhav, Honorable Ajay Sheh Dikkat, Honorable Lobaji Chavan, and all the CDC members, and all executive members of Marathwada Shikshan Prasarak Mandal. On behalf of them, I welcome you all. Friends, ours is a institute which is located in historic place Kille Dharur and has acquired A grade in NAC reaccreditation for the third cycle. Now we are facing for the fourth cycle, and soon we will be having the accreditation for the fourth cycle. Friends, our honorable office holders always motivates us for such national and international events and inspires us, enhances us for these events. So for this event, I just introduce this international event, that this nanomaterials and also material science is a provoking and inspiring subject, as we know that material science has provided various important applications from medical field, radiology, energy generation, and also the nanomaterials has a good strength in and quality in various products. I hope the outcome of this workshop will definitely benefit the faculty of physics, chemistry, and will enhance the knowledge of budding researchers as well as all the faculty of physics and chemistry. Lastly, I request all the participants to be live for all the sessions for 2 days till the end and take the benefit of this workshop for your future research and also future projects. And I wish you all the very grand success and all the best for this international webinar workshop. Thank you. Over to Dr. Bosley, sir. Dr. Ram Bosley. Dr. Ram Bosley. Ram Bosley, your voice is not clear.
He may be having something network issue. That's why he may be unable to connect. Just wait.
So lastly, I forgot to introduce my head of the department from Bhagwan College, Asti Chemistry head of the department, Dr. Zare sir, and also Dr. Zine sir, who are also organizers. So I wish you all the best for this international workshop. Thank you. Over to you, Ram Bosley, sir. Dr. Ram Bosley.
Thank you, sir. Thank you so much.
Yes, continue.
Thank you, sir. Now I request our co-organizer, Honorable Dr. D.T. Wak, sir, Principal, Bhagwan College, Asti, to share their views in front of us regarding this international event. Professor D.T. Wak, sir, please.
Good morning, all of you. I am Principal Dr. Dattatreya Wag, Bhagwan Mahavidyalaya, Asti. Today we are going to organize 2 days workshop on recent trends in nuclear science and material science. For this international event, we are gathered together today on the occasion of the Dr. Sarvapalli Radhakrishnan birthday. So all of you have a good wishes for this Teachers' Day. In this workshop, MSP Mandal's Arts, Commerce and Science College, Kille Dharur, affiliated to the Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, and Department of Chemistry, Bhagwan Mahavidyalaya, Asti, affiliated to Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. These 2 departments are organized the 2 days workshop on recent trends in nuclear and material science. For this event, in the collaboration, Dr. Principal G.K. Kakade sir and my colleagues of the professors from the Department of Chemistry, they will take given more efforts in this workshop. The speakers, Professor B.N. Dole sir, I am also welcome him with the Professor H.O. Tekin sir, Professor in Medical Diagnostic, University Sharjah. So these are the two resource person, eminent personality for the as a speaker in this conference, in this workshop for first day. On the second day, Professor Power Ma'am, Department of Physics, Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, and Assistant Professor Dr. D.K. Gaikwad sir, Department of Physics, SCS College, Dharangan, District Jalgaon. Professor Dr. Kakade sir has given more efforts in this collaboration, and my college has got a opportunity to organize this international 2 days conference. In these events, the international conference on recent trends in nuclear science. So I'm the person from the life science background. Chemical science. But today we are getting a more knowledge about the nuclear science. Firstly, the nuclear science is the study of an atomic world. Today we have just sort of knowledge about the war of the Ukraine and Russia. These are also one kind of an recent example of these nuclear science applications. So in this nuclear science, we are going to study about the atomic nuclei and its constitution. Along with that, in my field, these material science and nuclear science are also related to nucleus. In biological sciences, nucleus is the major term. Without nucleus, we can't do anything. Same as it is in the nuclear science, and material science also has a major background in this world. Along with that, it shows different kinds of applications are also seen in this field. The nuclear physics, its applications are also seen in many fields as a nuclear power, nuclear weapon, nuclear medicine, and magnetic resources, industrial and agricultural isotopes. These are the different kinds of applications we are going to use. So in these nuclear techniques and tools are also expert of the, we can study. In this study process deals with the pollutant as well as the environmental constituted or contaminated site also. In these contaminated sites, we are going to listen as a majorly the aspect of the environmental factors. In this environment means we have to study about these nuclear aspects, study upon the history of the environment, as well as the environment system, how to function it, how to use these nuclear applications in the environmental aspect, in the form of an impact interactions, as well as human welfare. So these are the major applications are seen from nuclear as well as the materials. Same as it is, this nuclear fission, electricity, nuclear weapon, as well as space exploration. These are the different kinds of applications we are going to use in these aspects. But along with that, the material science are also seen in majorly. Our speakers, Professor H.O. Tekin, from the background of medical science, and he given as these techniques, these isotopes, these applications are also how to use in the medical science as well as perfectly. Medical science means they are coming related with the human science also, and how to prepare different kinds of medicine techniques are also for the survival of an well-settled life of the human health. For this purpose, so these conference, these workshop, given a major and useful ideas to the delegates, dignitaries, and all the participants and students also. So for these events, I will give a major best wishes to the organizing committee, as well as the once again giving a thanks to resource person and principal of the Dharur Arts, Commerce and Science College Dharur, Professor Dr. G.K. Kakre sir, and my colleagues also, Dr. Jine, Dr. Zare, Dr. S.P. Donde. Along with that, all of you have a good wishes for conduction and active participation to all of you for the running of these events. So once again, I thankful to got this opportunity to express my views with you. So thanks to all of you once again, and over to Bhosle sir. Thank you, sir. Over to Bhosle sir.
Thank you, sir. Thank you, sir. Thank you, sir.
Okay, thank you, sir.
Now, the remaining participants can join our YouTube link. We have sent it in chat box and on YouTube group, WhatsApp group. We are facing some technical issues, so I request you to please wait for 5 or 10 minutes. Our keynote speaker is joining soon to us. Just stay tuned. Thank you. Participants are over 100, so the resource person are not able to join. Wait for 5 minutes.
असं कंटिन्यू चालू ठेवा.
Dr. Ram sir, please ask to Roy sir, please join.
Yes, he is joining now. Just wait for 2 minutes.
इश्यू यायला लागला.
श्रीकांत सर,
Yes, sir.
काही जे पार्टिसिपंट आहेत कॉलेजचे त्यांना सांगा YouTube लिंक वर जॉईन व्हायला.
सांगितलंय मी काही
रिसोर्स
रिमूव्ह
पर्सन आहेत त्यांना जॉईन
डोळे सर
होण्यासाठी.
जॉईन झालेत का?
हा?
डोळे सर जॉईन झाले का?
नाही, वेटिंग रूम मध्ये आहेत ते.
जस्ट अ सेकंड.
आले का सर?
Sir, please ask him to join.
Just wait for 2 more minutes.
Dr. Ram, sir. Hello, Dr. Ram, sir. Please ask to Dore, sir. Please join.
I request participants to join on YouTube link, please. So that the resource person can join. I request participants to please join on to the YouTube link, which we have provided into the chat box.
Recording in progress.
Till our research person join, I think I would like to introduce to our resource person, Professor B. N. Dore, sir. May I proceed, sir? Dr. Ram, sir.
Just a second.
Ram sir, please continue. Dr. Ram. Ram sir.
Yes, sir.
Continue the workshop.
Yes, sir. Yes, sir. Sir is joining now.
Delete.
Our keynote speaker is joining now, sir.
Dr. Ram sir, please contact to Dore sir and ask him to join because now 3 seats we have. He can
Yes, sir. I'm
accommodate in the
contacting
meeting.
now.
Welcome, Professor. Take you, sir.
Good morning. Can you hear me? Hello?
Yes, sir, we can hear you.
Yeah. Morning, everybody.
We are starting the keynote address. Just a minute, sir.
So I do responsibilities on the parents, or why husband one, or information register and local to it to facilitate the connection.
Hello everyone. Sorry for the interruption. Dr. Dore sir is on the way. He will join in the 5 minutes. So before proceeding on this today's session on the hour, we have in morning we have the lecture of Dr. Dore sir, and in the second session we have the lecture of Dr. Professor H.O. Tekin sir, and the same session along with tomorrow we are going to continue of in the morning session. We will like to will the session of Dr. D.K. Gaikwad sir, and in the second session there will be a resource person, Dr. P.P. Professor P.P. Power ma'am. So currently till now, till the Dr. Dore sir will join, so I would like to give his introduction. Honorable Professor Dore sir has completed his PhD degree in 2002 at Department of Chemistry, Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. He has received many national and international recognition and the award from the various institutions. Sir has 25 years of teaching experience as well as research experience. Currently, sir is acting as a head of the department at Department of Physics, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. He has been working as a member of Board of Examiner, and he has delivered more than 450 talks on the various topics at various institutions or at college levels. Under his guidance, 5 students has completed their PhD degree, as well as presently 3 are working under his able guidance. And sir has a number of publications during his research activity. Honorable sir has published his 122 research publication in various national and international journals. Among these, 57 are ASIA journals, 5 in national peer-reviewed journals. Sir has completed research project near about 42 lakhs rupees of reputed government institute as well as research institute. And presently 2 projects are funded by SERB, DST or DAE. And the expertise of the sir is in material science and specification, synthesis of doping materials, growth of nanocrystals, synthesis of HTSC material, renewable energy, photovoltaic cells, nanowires, nanosheets for the solar cell and the supercapacitors. These are the some expertise of the Honorable Dore sir. Honorable sir is also working as a reviewer in various national and the international journals. So, and some highlight and achievement of the Honorable Dore sir is he has his articles is ranked or he got awarded in world's hottest article across the world, and the rank is 22 in April-June 2011 issue. Sir has received Rashtriya Gaurav Award at New Delhi in 2012. Sir has received Excellent Teacher Award in April 2013. Also, Professor Dore sir awarded with Ideal Teacher Award of Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. So, such eminent personality is here, is among with us to deliver a lecture and to guide us for the keynote address. So, I think we are eagerly, everyone is eagerly waiting for his keynote address. So, I request to Honorable Head of the Department, Dr. Dore sir.
Just a minute, sir.
Dr. Dole sir is facing some technical issues. Thank you so much, Shrikant sir, for introduction of Dole sir. Dole sir has joined us. Welcome, Dole sir. Respected Dole sir, can you hear me? Hello. Please unmute, sir.
Hello.
Yes, sir. Can you hear me?
Yeah.
Okay,
Is it
sir.
audible?
Yes, sir. Yes, sir.
Okay.
Thank you so much, Shrikant sir, for briefly introduction of our chief guest and keynote speaker, Professor Dr. D.N. Dole sir, who is the keynote speaker for this international workshop. Welcome, Professor D.N. Dole sir.
Okay.
Now, may I request Honorable Professor Dole sir to deliver the keynote address to our participants. Please, Honorable Dole sir.
Okay. Thank you, Dr. Ram, who is the convener of this 2 days international workshop on recent trends in nuclear science and nuclear science and material science. I welcome those are directly joined for this workshop and those are online for this workshop. I heartily welcome all the participants, those who have joined for this workshop. The principal of Arts, Commerce and Science College, Kille Dharur, Dr. D.T. Wagh, and Chief Organizer, Dr. G.K. Kakade sir, who is the principal of ACS College, Kille Dharur, and Wagh sir,
Please mute other participants. Please mute. Yes, sir. Please continue, sir.
Yeah. The co-organizer, Dr. D.T. Wagh, principal, Bhagwan Mahavidyalay, Geurai.
Sir,
Hello, Principal Bhagwan Mahavidyalay, Dr. D.T. Wag, and Principal J.K. Kakade, Principal ACS College, Kille Dharu, who is the chief organizer and convener of this 2 days international workshop, Dr. E.L.B. Jadhwar, Department of Physics, ACS College, Kille Dharu. Organizing Secretary Dr. R.R. Bhosle, the Department of Physics, ACS College, Kille Dharu, and Joint Secretary Dr. E.S.P. Dhonde, Department of Chemistry, ASTI, co-convener Dr. D.S. Zhare, co-convener Dr. B.S. Jhine, and the other my colleague Professor P.P. Pawar and the D.K. Gaikwad, who will act as a resource person, and he appointed as a resource person for this 2 days international workshop. And one is from abroad, Professor H.Q. Tekin from United Arab, that is Arab Emira, Sharjah. As we know that what is the recent trend in the science, and we have to describe the concepts which are highly concerned with the material science and nuclear physics. All the online joint delegators, and here the recent trend, that is the recent trend in nuclear science. As we know that what are the recent trends in nuclear physics, and particularly in the subject of nuclear physics and in general in science. We have to describe and elaborate the terms, and therefore keeping that view in mind, the principal of both the colleges and the organizers and conveners put this concept, the recent trends in nuclear science and material science. In material science, what are the recent trends, particularly in the field of research? Means nowadays the world is going to cross that barrier, and therefore here the organizer put their ideas jointly. This is the era of interdisciplinary science, interdisciplinary subjects. Means the how one subject is correlated with the other, and there is the existence or presence of that subject. I mean, in case of the nuclear physics, nuclear science, without the material science, it is not possible to describe, to synthesize the material. Here, the conveners or coordinators try to bring to face these two concepts. I would like to elaborate and enlighten that term. How the nuclear physics and how the material science both are joined together, so that the resource persons will give the justice to these two topics. I mean, the nuclear physics and material science. Now come to this point, the nuclear physics is that concept. Here is the nowadays across the world, as you know that what is happening in Ukraine, the war is going on, but there is that fear of nuclear weapons, okay, that nuclear bomb. If the Russia takes that decision, and if the nuclear bomb is dropped, what will happen? That is again how to keep the human being safe from such a weapons. Means my submission is that, my sincere submission is that, how to control the things, and therefore the nuclear physics is there. Again, keeping that uranium, thorium, all these, means these are the radioactive elements. These elements, how to synthesize the things again, but after synthesizing, how to keep and save the human being, that is the present challenge. Because okay, synthesis, fabrication, all these things are okay. Nowadays we can achieve that target across the world. As you know that in Iran is trying to synthesize, to prepare, to make atom bomb, but America is telling to very free and frankly, America is resisting, do not take this step, because this due to this, what will happen? The human being will annihilate. But Iran is not listening. These are the challenges. But in the nuclear science, keeping that you in mind, the research area, here is the huge research area. Those are newcomers. They can join and they can do something innovative. I mean, in nuclear physics, they can do. Even in our country, Bhabha Atomic Research Center is there in Kalpakkam, ICAR, Kalpakkam, there is that one. Even though in Inter University Accelerator Center, New Delhi, there is that center. In Kolkata, there is that center. There are the centers, and research is going on using these elements. Means how to find the how to analyze the material, how to characterize the material, and how one can understand the materials and its crystal structures. Using these techniques, neutron diffraction technique, using that one can understand the crystallography of the material, and therefore this is the trend, and one can concentrate. Another thing is that how one can correlate this idea with the material science. In case of the material science, here is also a huge area and huge challenges, but those are interested to join this this burning nowadays it is a burning topic, because the most of the people, they are concentrating on how to design, fabricate and synthesize the new aids, new materials. I mean, okay, capacitor is there, but we have to fabricate using the nanomaterial, and therefore it is termed as a supercapacitor. Photocatalytic activities, antibacterial activities, one can study using this one. But before touching to this, there are the number of synthesis routes. Using these synthesis routes, one can fabricate. But thing is that this is a challenging branch. Material science is also the challenging branch, and this newcomers, those are interested, these newcomers also can accept that challenge and start their work. They can begin their work using this one. What are the challenges? What are the strengths and what are the weaknesses of these branches? One can easily understand through the following statements. Number one, challenge means this is the burning topic, and those who will concentrate, then they can start their work. For example, in case of the ZNO, ZNS, MN, MNO, okay, TiO2, TiO, CuO, these are the systems. using these systems, you can start your work. But point is that, so what is your plan? If you plan and you start your work, then definitely you will get the very interesting things. And therefore, as I mentioned, the energy storage devices nowadays across the country and globe. So how one can store the energy, and when you want to use, then you can use, but the storing capacity, and therefore we have to fabricate such a devices, that is the energy storage devices. These are the concepts in the material sciences, even though including all these. And now one can correlate this idea with the nuclear science, yeah, nuclear physics, and this material science, yeah, one can correlate. There is the coexistence of this. Again, not only this, but the electronics also, you can correlate our idea with the electronics and spectroscopy. Okay, these are the four branches, but here the convener outline and given this topic, that is the international workshop on nuclear physics, yeah, nuclear science and material science. Okay, now from my side, this is the keynote of this international 2 days international workshop on nuclear science and material science. Those are newly entered the field, they can concentrate, they can select the topic, but before selecting the topic, one has to find that dimension, whether is it possible at our place or not, because those are interested, but only interest cannot function, cannot streamline. Why? Because without the characteristic techniques, one cannot proceed, and without the synthesis routes at your place, these primary things should be there. And if these primary level things are there, I mean the synthesis route, then for the characterization you can approach. Even in the Department of Physics, Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, we have the number of techniques, that is the characterization techniques and synthesis routes. Because your convener, Ram, he worked in our department as a research fellow, and he knows the things available in the Department of Physics. You can utilize these facilities, those are at our department. For example, we have the Raman, we have the X-ray diffraction, we have the UV-VIS technique, we have the pilot machine, we have the following certain synthesis routes, that is the CLR, CBD, electrochemical, then the sol gel, hydrothermal. These routes are at our laboratory, and one can utilize this facility. After synthesizing the material, but only thing is that Ram knows, and your another convener, Jadhor sir, because they spend their valuable time in the Department of Physics for the research purpose, and they done their work at this department and published the research papers in report international journals. So only research interest, okay, that is very interesting thing, but this is interest in the research, it is a primary level. As you know that in the KG, so the students don't have that much understanding, but their parents register their names in the KG. Here in the research, your interest is important, but it is primary level. After the entering the research field, then you have to start your work. Okay, and selection of the topic, selection of the title is very important. Nowadays, the terms are changing and we have to we have to understand all these things. And therefore, if you concentrate properly, if you select your topic, definitely at the national level and international level, your work will be identified and we will get that identity. Okay, this fellow is working on this field, and then your identity, you will get that recognition at national level in the field of research and international level. Therefore, we have to understand this phenomena. With this, I must congratulate the organizing secretary, Dr. R.R. Bhosle, and Joint Secretary, Mr. E.S.P. Dhonde. Convener of this 2 days international workshop, Dr. E.L.B. Zadwar, Department of Physics, ACS College, Kille Dharo. Okay, and co-organizer, Dr. D.T. Wag, Principal, Bhagwan Mahavidyalay. Chief organizer, Dr. G.K. Kakade, Principal, ACS College, Kille Dharo. And those are joined for this international workshop online and offline. I must say here, I am grateful to these fellows because they joined for this workshop. And I have given the keynote on this 2 days international workshop. And now I would like to concentrate, but I hand over the charge to the organizing secretary, Dr. R.R. Bhosle, and thereafter I will enlighten my topic, that is the current trends in nanotechnology. Now, Dr. Ram Bhosle.
Thank you so much. Thank you so much, Honorable Dole sir, for brief keynote address. Now, I request Professor Dole sir to please start their topic onto the nanotechnology.
Okay.
Okay, sir.
Yeah. Thank you, Dr. Ram, organizing secretary of this 2 days international workshop.
Okay, thank you, sir.
Pen drive. You open recent trends in
Sir is delivering a lecture on to the topic current trends in nanotechnology. How current or how nanotechnology research is going on nowadays. Sir is explaining us in brief.
हाँ ये चलता ओके या खाली खाली है ना हाँ कुठे हे पेन ये चलता
हाँ बोला ना
हाँ आता
सवारी बनावता था श्वेता मेरे को सवारी बनावता था श्वेता मेरे को
करण हाँ Ram, is it open, clear, visible?
No, sir. Screen is not visible to us.
No.
Share your screen, sir.
Now?
Yes, sir. Yes, sir. Okay. Is it visible, sir?
Okay. लाईट नाही काय थोडा विजय
Yes, sir.
हाँ हाँ ओके लाईट आपलं चेहऱ्यावर कसं कहा लावायचं इकडं हाँ hello is it audible
Yes, sir.
okay may I start now
Yes, sir.
हाँ
Sure.
okay हाँ 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 okay current trends in nanotechnology. So myself, Professor B.N. Dole, from Department of Physics, Dr. Babasaheb Ambedkar Marathwada University. And today I would like to enlighten this topic, that is the current trends. As you know that this is the name of this workshop is also recent trends, okay, in nuclear science and material science, okay. And the topic of my today's lecture, that is the current trends in nanotechnology. This is the outline of my presentation. That is what is nanotechnology, its introduction, nanoscale, nanomaterial, and possible characteristic techniques and approaches of nanotechnology, and that is the top and bottom up and top down approach, and what are the applications, and for the environmental, water purification, and conclusion. All these things I would like to cover. So here what is a nano, as you know that because we people are familiar with the scale, and that is known as the meter scale, okay. But here, and in this case, the scale is totally different. One cannot handle that scale. One cannot use that scale in a present scenario. But there is that scale, existence of that scale, and we can. So here the matter and energy are manifestations of the universe. They exist in a variety of forms and interact with each other in many ways. So one can understand that from this. The matter, if matter is there, material is there, it means there is the existence of energy. And if material is not there, there is no existence of energy. So through this concept, one can easily understand material has a energy, and if it carries the energy, it has that energy, it means one can say there is the manifestation of this term. Energy, matter and energy are the manifestations of the universe. So energy is nothing but the capacity to do the work. Material functions, that material has that capacity, and therefore you can say the matter and energy both are manifestations of the universe, and they exist in a variety of forms and interact with each other in many ways. Therefore, so very soon, because if you see the legacy, yeah, if you see what happened in ancient era, there was, the man was unknown with the term of science, but nowadays from the science we are going, we are studying the terms, and then the human being came to know what is a science. Parallel as a lie. So if you compare with this, then one can understand that the scale, meter scale, from meter scale to millimeter, from millimeter to micrometer, and from micrometer to nanometer. This is the downscale and what is the upscale. Means the meter, then the kilometer, okay, kilometer, then mega, okay, and giga. So nowadays these words are familiar. Giga, gigabyte, okay, and in case of the mobile, these terms are used. That is giga, G, okay, geo, okay, in mobile it is used, okay. Now means your pen drive, okay, pen drive, not nowadays the kilobyte but gigabyte, okay. So means G, it has that capacity to store the more data. Like that, this is this scale. Now go to down, and as I mentioned here, giga, there nano, there is that change. Means one scale is a gigameter and another one is nanometer. Nano, one is the plus 10 raised to, means 10 raised to plus 9, the another one is the 10 raised to minus 9. That is nanometer is 1000 millionth of a meter, billionth, okay, billionth of a meter. Now to understand how small 1 nanometer is, let us see few comparisons. We know that RBC is approximately 7000 nanometer wide. See, 7000 nanometer wide. Our red blood cells, water molecule is almost 0.3 nanometer across, water molecule, and our hair is about 80,000 nanometer wide. So this is means the meter nanometer scale, and now we people are familiar with this. Nanometers could be defined as the materials with at least one of its dimension in the range of a nanometer. So one can understand from this the nanomaterial, how one can understand, and we people studied that one in case of the material science, the Bravais lattices in 3-dimension form, in 2-dimension form, but in 1 dimension, then we went, means there is no explanation regarding the 1 dimension and 0 dimension or dot, okay. But here in nanomaterial it is possible, in nanoscience it is possible. Therefore the material need not be so small that it cannot be seen, but as a large surface or a long wire whose thickness is in the scale of nanometer, okay. So materials that are nanoscale in 1 dimension are layers such as thin films or surface coatings, okay. So nanoscale, one can now from this one can understand. So it is in a thin film form or surface coatings, okay. These are in 1 dimension. Now another case, the materials that are nanoscale in 2 dimensions, wires and nanotubes in 2 dimensions. Please, participants are requested to put your mobile on mute mode. Participants are requested to put your mobile on mute mode, okay. So, hello. Now materials that are nanoscale in 1 dimension, and these are in the form of layers. So thin films or coatings, wires and tubes are in 2-dimension form. And as we know that because the area and all these things we can outline or confine in the form of 2 dimensions, okay. Now in case of the 3 dimensions here, but now come to the 0 dimension. 0 dimension, the materials that are nanoscale. So here it is just this is not the example of this one, but another, as we know that the materials 0 dimension here, in spite of 0 zero dimensions, the particles, for example, precipitates, colloids, and quantum dots. These are the small particles of semiconductor materials, okay? And these have the means quantum dots. I mean, the dot is a zero dimension. The dimension, I mean the three dimensions, x direction, y direction, yeah, x axis, y axis, and z axis. There is totally, absolutely absence of these axes, and therefore it is a dot. And this is the material that are nanoscale in zero dimensions. Now, what is a nanoscience? This is the term used nowadays. Science is well known, but what is a nanoscience? It is defined as the study of phenomena and manipulation of materials at atomic, molecular, and macromolecular scales where properties differ significantly. Here, what is a nanoscience? Because this term, this phenomena is nothing but the manipulation of materials. Okay, manipulation of materials at atomic or molecular level. Here, what happens at this scale? At this, I mean nanoscale. At nanoscale, the material changes its properties drastically. Material changes its properties drastically. One can understand through this why the nanoscience is important, because the material nanoscience plays a pivotal role, very significant role in this, and therefore one can understand that the properties, the material changes its properties drastically at a scale that is a nanoscale. Means the bulk material has the different properties, but that material, if you synthesize at nano level, then the same material will change its properties. Nanoscience is the study and understanding of properties of nanoparticles. Nanoscience is nothing but the understanding of the properties of the materials, understanding of the properties of the materials. Okay, understanding of the properties of materials at nanoscale. I mean nanoparticles, properties of nanoparticles. Understanding of properties, I mean the characteristics of nanoparticles. What is nanoscience? Nanoscience is a simply term as understanding. Nanoscience is nothing but the study deals with the nanoparticles. How the particles behave differently from the bulk level at nano. Nanotechnology can be defined as the design, characterization, production, and application. Nanoscience, understanding of the properties. Okay, this is the, one can say, foundation, basic, fundamental. But technology means design, then produce, characterize, design, produce, design, characterize, produce, and see the possible applications. And if you are able to design, characterize, and product its applications, then fabricate the devices. What is nanotechnology? Nanotechnology can be outlined as such: to design, characterize, product, application, and structure devices and systems by controlling shape and size at nanometer scale. Nanoscale scale, okay. The why properties of nanomaterials are different. Now try to understand, please. Now those are joined online and those are present there offline. Please concentrate on this slide. See. The properties of nanomaterials are very much different from those at a larger scale, as I outlined and elaborated this term. Two principal factors cause the properties of nanomaterials to differ significantly from other materials. Two principal factors cause. These are also important. Which are these? These are termed as below. As below. These are outlined here. Increased relative surface area. Okay. Another one is quantum confinement effect. Now, see, these are how important. If you go this, Dhonde sir, is there Dhonde sir? Dhonde sir?
Yes, sir. Yes, sir. Yes, sir.
Is it audible?
Yes, sir. You are audible.
Now getting what I am describing.
Yeah.
I have described these terms, okay? Nanoscience, nanotechnology. Now,
Yes, sir. Everyone is getting.
okay, okay. Now here the surface area to volume ratio is very large. Another point is that the quantum confinement effect. Now you see at that quantum level, at that dot level, if the material is below 10 nanometer size, below the 10 nanometer scale, so then the material behaves as a quantum confinement effect. Now why these are important? Up to means from 0 onwards, 1 to 100 in that range, nanometer scale, that is the material is a nanometer. If you synthesize the material using, as I stated, the synthesis techniques, I name here the Solgel route, Silar route, spray pyrolysis route, CBD, then the hydrothermal route, then the electrochemical, electrophoresis. These are the routes, and using these routes, you can synthesize the nanometer scale materials. And we successfully synthesized at our level in our laboratories. And we characterize the material using the following techniques. I will touch later on because I want to cover this. Now, these factors can change or enhance properties. Okay, these factors can change or enhance the properties such as reactivity, strength, and electrical characteristics. Now, increase in surface area to volume ratio. Sorry. Enhancement in a surface area to volume ratio. What type of enhancement we have to see? Here, the nanomaterials have a relatively larger surface area when compared to the same volume or mass of the material produced in a larger form. Okay. Let us consider here the formula is given. That is the surface area. We know that here in case of the sphere, we are describing sphere. Consider a sphere and its radius is r. Surface area is 4 pi r square. Then its volume is, what is that? The 4 by 3 pi r cube volume. Okay. So here surface area to volume ratio. Now surface area to volume ratio is 3 by r. This is calculated and given. here its volume is 4 pi r cube upon 3. Volume is 4 pi r cube by 3, and then surface area to volume ratio. Now this is 3 by r. So therefore, the radius of the sphere decreases, its surface to volume ratio increases. Now you see how one can correlate experimentally. Zare sir, Dr. Dilip Zare sir. Hello, Maqsood. Dr. Maqsood is there.
Yes, please unmute yourself.
Mute. Okay, now you see radius increases, surface area to volume ratio decreases. If you take the value of r, means this sphere value, radius of sphere is r, then it increases r. What will happen? The surface area to volume ratio decreases. Okay, surface area to volume ratio decreases. If the radius of the sphere decreases, okay, now the volume ratio, this volume ratio increases. Obviously, the radius decreases, I mean the sphere radius decreases, volume ratio increases. And if the volume ratio, it means the surface area to volume ratio is very large. This is the surface area, how one can calculate. This is the cube, from this one can. Now let us consider 1 cubic volume shown, it is in surface area, that is the calculation is given here, and this is very simple. When it is divided into 8 pieces, its surface area becomes 12 meters square. Similarly, when the same volume is divided into 27 pieces, its surface area becomes 18 meters square. So means the surface area value of r, okay, value of r here increases. So it is outlined here. Value of r, I mean value of r means the sphere decreases, number of spheres. Now see here, and therefore here again surface area, how one can calculate for this cube. So it is given. Now what is the quantum confinement effect? As I mentioned, nanocrystals, the electronic energy levels are not continuous in case of nanocrystals, as in the bulk, but are discrete finite density of states. We studied this in material science or solid-state physics because of the confinement of the electronic wave functions to the physical dimensions of the particles. So this phenomena, what is that? The bulk electronic energy levels are not continuous in nanocrystals because of the confinement of the electronic wave functions to the physical dimensions of the particles. This phenomena is called quantum confinement, and therefore nanocrystals are also referred as the quantum dots. What is nano? This phenomena is also called the quantum confinement, and nanocrystals are referred as the quantum dots. Properties of nanomaterials. Nanomaterials have properties that are different from bulk materials. Most nanostructure materials are crystalline in nature and they possess unique properties. So what is the nanostructure materials? Most of the nanostructure materials are crystalline in nature, and possess unique properties. The physical properties of nanomaterials, crystal structure of nanoparticles is same as bulk structure and different lattice parameters. Okay, so here it is very interesting. In case of the crystal structure of bulk material and nanometers are same, but only thing is that change in lattice parameters. Okay. The interatomic spacing decreases with size and is due to the long range electrostatic forces and short range core repulsion. So melting point of nanoparticles decreases with size also. The chemical properties of the nanomaterials are outlined in this slide. Nanoclusters to react depends on cluster size. So the large surface area to volume ratio, variations in geometry and the electronic structure of nanoparticles have a strong effect on catalytic properties, as I mentioned. And we people are also studying these catalytic properties, photocatalytic activities, and antibacterial activities. But catalytic activities, catalytic properties change. So here the electronic properties of the material. The electronic structure of nanomaterials is different from its bulk material, as I mentioned. Electronic structure. This is also very important because the structure, electronic structure is present in the bulk material, but the same structure will not present at nanoscale. That is electronic structure change. Density of the energy states in the conduction band changes. So here the density of energy states in the conduction band changes. When the energy spacing between two energy levels is more than kBT, energy gap is created. So energy spacing between two energy levels. And therefore the nanoclusters of different sizes will have different electronic structures. As I mentioned, at nano level and at bulk level, the same material at bulk level, its electronic energy, electronic structure is different. And at nanoscale, nano level, nanomaterial has the change in the electronic structure. Ionization potential at nano size and at bulk level will be the higher. Ionization potential at nanoscale will be the higher than at bulk level. Magnetic properties. Okay, the magnetization. Magnetic moment of nanoparticles is found to be very less when compared them with bulk size, with their bulk size. Okay, magnetic moment is changed again, and it is found in case of the bulk material, it is higher. Okay, electronic structure, okay, at nano level is higher, but at this magnetic moment of nanoparticle at nano level, it is lower than the as compared to the bulk size. Nanoparticles made up of semiconducting materials, that is from germanium, silicon, cadmium. Now these are the nanoparticles are they are fabricated nanoparticles from the semiconducting materials, that is germanium, silicon, cadmium. Okay, again, what is the as I mentioned, characterize means design, characterize, application, design, characterize, product, and application, and then the fabrication of devices. This is the nanotechnology. Why nanoscale? Because nanoscale is 1,000 millionth of meter. People are interested in the nanoscale because at this scale, physical and chemical properties of the materials differ significantly and show the something new, show the innovative properties. And this is the, you see, atom, it is a 0.1 nanometer. Its size means scale, see, 10 raised to minus 1 means scale 10 raised to minus 1 meter. Here this is a 0.1 nanometer. Okay, 0.1 nanometer. This is a 10 raised to 0. This is 1. As we know that mathematics, 10 raised to 0 means 1. And this is the 1 nanometer. And this is the DNA diameter. 1 nanometer is the DNA diameter of DNA. And the 5 to 10 nanometer, okay, 5 to 10 nanometer is the carbon nanotube diameter. In that scale means this is in quantum dot, okay. 10 raised to 1 means 10 raised to 1 means 10 nanometer, and it is the size of protein, okay. And transistor 35 nanometer, okay. And 10 raised to 2 means 100 nanometer, okay, 100 nanometer. 10 raised to 3 means 1 kilometer, 1 kilometer, right? And what is the RBC? RBC is the 10 raised to minus 6 meter, means 10 raised to means this is the here 10 micrometer, means 10 raised to minus 6, okay. And this is 10 raised to 4. 150 micrometer is the human hair diameter. The human hair 150 micrometer means 150 into 10 raised to minus 6 meter, okay. This is the scale. I described this, and this is the carbon nanotube, okay. See the structure of this one. And what is the nanometer, noble metal nanocrystals and cyclic penta twin structures. These are the structures, and we have prepared these structures in our laboratory. This is the hexagonal structures. This is the wire-like structure, okay. All these, and this is the shape pattern of the material, and we have prepared in our laboratory successfully. A nano powder, you can see this is the nano powder, and this is also I covered. This is covered characteristics of the nanomaterials as I described. Category 1-dimensional, okay, and 2-dimensional, as I mentioned here, the 1-dimensional platelets and surface coatings and thin films, okay. 1-dimensional nanomaterials. 2-dimensional is nothing but the nanotubes and nano wires, okay. And 3-dimensional, that is here typo mistake, but as we know that the materials in case of the 3-dimensional is the hexagonal. Here is the hexagonal materials. These are also then the nanocrystalline, when this is the bottom up, bottom down approach. Here is the top down approach. The bulk material cuts into small pieces, and see this is the top down approach. What is bottom up approach? Means the material is in the nano form and we have to form a bulk material. So these are the applications in case of the medicine, diagnostics, drug delivery, tissue engineering, and cryogenics, information and communication, heavy industry, that is aerospace, catalysis, then the construction of vehicle manufacturing, consumer goods. This can be used. There are the huge applications for this. Then the wastewater treatment one can, and here we are also working on this. And in another case, in that is the energy. So we are also working on this, and then we have tried, and we have some products also. Those are interested, they can visit to Department of Physics and particularly Advanced Materials Research Laboratory, okay. And my students are also working there round the clock, and our research team, our research group working around a clock to design, to fabricate the materials. Synthesis and characteristics, these are the primary primary level work, but beyond that, we have produce some products, and those are interested, they can come to see. Nowadays, we are also going to fabricate the supercapacitor. Okay, water purification, as you know that nowadays in our Maharashtra and in our country, the rainy season is there. How much water we are able to store? Our capacity is very less, and plenty of water uh, uh, goes. Plenty of water is in waste form. Okay, but over 75% of the earth's surface covered with water, and we are not able to clean it. 97.5% of this water is salty water, leaving only 2.5% is a fresh water. Now we have to develop indigenous technique to purify such type of water, and we are also working on this. Now, global water budget, less than 1% of the world fresh water, 0.007% of all water of earth is accessible for direct human uses. Therefore, if we develop such a innovative technique using the nanomaterials, then definitely this water will be used as a potable water. Detection of target analyst, metals, nutrients, and algae, biological agents, innovations in nanotechnology and nanoscience are having a significant impact in biodiagnostics, where a number of nanoparticles based and assesses and nano devices have been introduced for biomolecular detection. Nanofibers and nano biocides. So as I mentioned, there are the plenty applications, and the nanomaterials may play the pivotal role in such a cases. And we can use the nanomaterials for this as an antibacterial activity, antimicrobial activities, and for the water purification. Nanomaterials and nano products can be engineered using the nanomaterials, and we are trying also at our level in our department. So as I mentioned here, the filtration purpose, we can use the nanotechnology could potentially lead to more effective means of filtration that not only remove more impurities than current methods. What are the current methods? You people, yeah, we people are familiar with the Kent water purifier, but it is also not a perfect technique to purify the water, because here, as I said, and here these nanomaterials, using the nanomaterials, if we are able to fabricate the techniques, then these products will be also the viable, usable, and these are the implications of nanomaterial used for environmental remediation, intentionally introduced into the environment to exploit its unique properties. Okay, now environmental, and now we listen that term, that is the green technology, yeah, green chemistry. Okay, for this also nanomaterials can be used. Applications of nanomaterials as fillers for point systems, coating systems, magnetic fluids, lightweight construction, painting, catalyst, and sensors. These are again the chemical industries it is used, and in automotive industry it is used as a sensors also. And as you know that the functions in medicine, drug delivery systems, active agents, these are the agents in cancer therapy also. It can be used in electronic industry, data memory, displays, laser diodes, glass fibers, filters, conductive and antistatic coatings. Okay, energy sources, fuel cells, solar cells, batteries, capacitors, and here we are using on solar cells. We are working on solar cells, batteries, and capacitors. This is in case of the energy storage devices. Cosmetics, sun protection creams, and toothpaste, it can be, these materials can be used. And this is the now another actual research work we have done. Now we are having the less time. We cannot concentrate much more, but what type of research we have done in our research laboratory and published the research articles. This is the nanometers, and this is the outline again, and these are the nanometers, as I mentioned: surface effect, size effect, quantum size, quantum confinement effect, thermal properties, electrical properties, optical properties. We can, and these are the materials we prepared in our laboratory. I just overview, I can take the overview of this slide: synthesis and characteristics of Yemen dope. We prepared the, and we started the work from the Yemen and prepared by the Sol-Gel route, and we published the number of papers in this. Now this is the slide how to synthesize the material using the Sol-Gel route and gel form here, and we got the ZN MNO material. And these are the XRD and the characteristics of this one. This is the analysis of the XRD pattern, the material characterized using this one, and here it increases. Now this is the transmission electron microscope. This is the house in the Inter-University Accelerator Center, New Delhi. And this is the TM images of our sample, and this is here they clearly explicitly outline that the material have the hexagonal structure, and here is the set pattern. And this is the absorption, means the UV-VIS pattern of our material, and from this we can calculate the energy band gap of the material. And now see here, energy band gap decreases as concentration enhances. And this is the vibrating sample magnetometer of our material we have taken here. This is the technique. Here is the electromagnets and all these things. Now this is the cusp hysteresis loop of our material, and here we found the magnetism. Magnetism is exists in the material, and here also the experimental setup for this vibrating sample magnetometer. And now you see here the paramagnetism exists in the material, and then lastly it shows the ferromagnetism which is present in, and we have calculated remanence magnetization and saturated magnetization. And here from this cusp you can say initially there is no presence of the, means MAC is absent, but step by step if the concentration enhances, then it shows the saturation magnetization. This is the another system we prepared. So many systems and materials we prepared in our laboratory. These are the few slides. Now due to the unavailability of the time is very less now. I want to wind up. Is it clear? And these are the conclusion of our X-ray diffraction study. Indicates that all samples have the oversight, hexagonal structure. Okay, trigonal, tetragonal, these are the structures in the Bryce lattices, but our system shows the hexagonal structure. Volume cell porosity, U parameter enhances with increasing Mn content, and C by A ratio and bulk density and X-ray density so increasing. So these are the parameters outlined here. Why this is important? Now the researchers may ask the question, but here in this case, because we studied this material for understanding the nanotechnology, nanomaterials at nanoscale, and we got the very interesting, pivotal, very interesting, significant results, and therefore we were able to publish the papers in the that time. The SCI journal was the new concept in our Maharashtra, but at that time we published the papers in the Science Direct journal, in the Current Applied Physics. That article appeared in the Current Applied Physics journal, and later on it was appeared in the News of Science in America. So News of Science, that was very, means we got the recognition for what we had done, because first time the doctor means B.N. Dole and his group obtain the material in the nanoscale size, okay, nanoparticle size, and publish the article on this. And so this is the experimental procedure. All these things are very interesting, but due to the lack of time is very less, as I mentioned. Okay, again, here is the synchrotron radiation facilities, and we also utilized these facilities are available at Raja Ramanna Center, that is the advanced technique, okay, yeah, technology. This is the RR CAT Center, okay, and we utilize the facilities at RR CAT Indore, and we got the novel results. So this is the case. Dr. Ram,
Yes, sir.
is there time, or may I wind up?
Sir, please
Wind up.
wind up, sir.
Okay. Now you see, as I mentioned, because your inaugural function, you wound up in a very short time, but now it is not possible to cover this
Yes.
all these slides, my topic in a half an hour. But okay, now due to this lack of time and unavailability of the time, I will cover. Now this is the angle dispersive X-ray diffraction technique we used for the characterization of our sample, and this is the chromatization using single crystal, and we characterize the sample. Okay, now peer distribution, all these okay.
Okay, sir.
Just a minute. Okay, see, Ram and all those are concerned with the research, highly concerned. Your concern with the research is very highly, okay. And now you see, in our laboratory in 2016, first time we prepared the nanowires, and these are the photographs of the nanowires, pure ZNS nanowires, okay. See, this is the nanoscale, and these are the elongated nanowires using the EMN doped. This is the cobalt doped ZNS nanowires, okay. 4% cobalt doped ZNS nanowires. See, these are the photographs of this, okay. See, this is the 100 nanometer while elaborating the concept nanowires. Now see, this is the TAME images, yeah, TAME photographs, and this is the shade pattern of the same. This is the research, okay. And now you see, we publish the paper in the Crystal Engineering Communication, and its factor was the impact factor 4.03. Royal Society of Chemistry, and this is the
Yes, sir.
elaboration of this one, okay. The another thing is that now you see, this is the very novel result, innovative results we obtain. See the same images of the samples, and we calculated the set, okay. See, flowers also we got. Sorry. These are the flowers we people used to say, and see the images of this one. And again, the another paper we published in this journal. Now see, these are also the flower-like structure. Do you know? This is just like the flower, and images, same images of our samples. See, photographs of the same. These are the photographs. And again, we publish the paper in the another journal. So these are the conclusion and future. You can prepare the samples as I mentioned, and if you want to utilize the facilities of our research, so research, see here, this is the slide, international journals, and we publish the papers in international journals. So these are the publications, okay. in SCI journals, not in local or Indian level journals, but only SCI journals. And as I mentioned that one, current applied physics. My article was appeared in April to June 2011 issue, and they appreciated the work. Okay, so this is the journal of this one. The current applied physics volume 11 issue 3 May 2011 pages this one. Okay, and this is the journal, and they appreciated our work. And thank you very much for attending this 2 days international workshop entitled Recent Trends in Nuclear Science and Material Science. Those participants have joined online and offline. Thank you very much. Lastly, I must owe my special thanks to Dr. D.T. Wagh, co-organizer, principal, Bhagwan Mahavidyalaya, and chief coordinator, chief organizer, Dr. G.K. Kakade, principal, ECS College, Kille Dharur, convener, Dr. L.B. Jadhavar, Department of Physics, ECS College, Kille Dharur, organizing secretary, Dr. R.R. Bhosle, Department of Physics, ECS College, Kille Dharur, joint secretary, Dr. S.P. Dhonde, Department of Physics, Bhagwan Mahavidyalaya, co-convener, Dr. D.S. Zare, Department of Chemistry, Bhagwan Mahavidyalaya, Asti, co-convener, Dr. B.S. Zine, Department of Chemistry, Bhagwan Mahavidyalaya, Asti. Thank you very much for giving an opportunity. Thank you very much. Now I hand over the charge to Ram Bhosle.
Thank you so much, sir, for elaborating and expressing current research in nanotechnology. Participants, anyone having doubts may ask. Questions, please.
If there is any doubt, the participants are requested to ask the question.
Thank you, sir. I think there are no questions.
Okay. Now I hand over the charge to Dr. Ram Bhosle.
Thank you, sir. Thank you so much for such an nice presentation. Sir gives us an idea that how important nanotechnology has become nowadays. Hope everyone enjoyed the lecture and took the benefit of this talk in future. Thank you so much, Honorable Professor Dore, sir. Thank you so much.
Okay, thank you.
Thank you. Now we have next session. Now I request Dr. B.S. Zine, sir, to please introduce our next resource person, Honorable Professor H.O. Tekin, sir, who is joined us from University of Sharjah, UAE. Please, Zine, sir.
Thank you very much, sir. May I audible?
Yes, sir. Yes, sir.
Okay, thank you, sir. Good afternoon, everyone, and warm welcome to second section of 2 days international workshop on recent trends in nuclear science and material science. I, Dr. Zine B.S., Associate Professor of Department of Chemistry, Bhagwan Mahavidyalaya, Asti, District Bid, Maharashtra. It is my immense pleasure to introduce this second section eminent person or speaker, Dr. Hussein Ozan Tekin, sir. Dr. H.O. Tekin, sir, is a professor of Department of Medical Diagnostic Imaging in University of Sharjah in UAE. Sir completed his MSc degree in nuclear physics under Süleyman Demirel University, Turkey in 2011, and also completed his PhD in nuclear physics under Süleyman Demirel University, Turkey in 2014. Dr. H.O. Tekin, sir, has 14-year experience at UG and PG level as well as research. Dr. H.O. Tekin, sir, have been awarded by different associations like Professor Dr. Şevket Yarke Young Scientist Award by Turkish Physical Society in 2018, Sir, also awarded as one of the most influential scientists by Stanford University, USA in 2020. Then, sir, also announced as a top 2% scientist in standardized citation indicator. Sir, also recognized as world top 100 scientists in United Arab Emirates in 2022. Dr. H.O. Tekin sir also ranked as 10th in United Arab Emirates as top material science scientist. He also got Outstanding Researcher Award in first place by University of Sharjah. Then Dr. H.O. Tekin sir have scientific interest in various fields like Monte Carlo simulations, radiation, nuclear physics, medical imaging, computed tomography, medical physics, radiological protection, nanotechnology, nanomaterials, MCNP code, medical imaging physics, radiotherapy, radiation protection, nanostructure material, digital imaging, etc. Sir also completed various projects and have research group experience in Turkish Accelerator Center, Süleyman Demirel University and University of Sharjah. Sir also have professional experience on Monte Carlo codes and computing programs. Dr. H.O. Tekin sir have been invited as a speaker or resource person in 18 international seminars, conferences or workshops and open interview sessions. Also, he also participated in scientific activities such as Congress Symposium and workshop. Sir also have been worked as a referee and editorial board membership in various international index journals. Sir also wrote 3 scientific books. Dr. H.O. Tekin sir have 286 publications, 286 means 286 publications in SCI indexed Scopus journals and 22 publications in other international index journals. Sir also published 75 abstracts or research paper in international congresses and symposiums. Sir also published 24 texts in national congresses and symposium. Sir also published more than 122 reviews, 122 reviews in Scopus, SCI and other index journals. Yet candidates completed their research work under his supervision. Under his guidance, BSc level students completed various research projects. This is the brief introduction of Dr. H.O. Tekin sir. Actually, I saw the biodata of sir, and that is 62 pages, but here I briefly introduce Dr. H.O. Tekin sir. So, may I request Dr. H.O. Tekin sir, please deliver your talk on medical and radiation protection application on Monte Carlo simulation techniques. Thank you very much, sir.
Thank you, Doctor, for your excellent opening. It gives me a really great pleasure to be here today with you. Before my speech, I would like to express my deepest thanks for the organization committee, for the institute, and especially for Dr. Ram. He was in contact with me for the days, and he was following strictly about the process, and my special thanks goes him. Especially I have a huge pleasure to be here today with an Indian society, because the Indian society, along with the nuclear sciences, along with the material sciences, along with their community in the computational sciences, they are the community that I really appreciated always. I mean, India has a special place in my heart in the scientific studies. At the beginning of my academic studies, I had a distinguished partner from Karnataka University, Dr. Singh. We published a lot, and he was a distinguished partner for me in my scientific journey. We are still in touch with him. I haven't visited the India in person yet, but hopefully this was the one point that I wanted to emphasize at the end of my speech. hopefully one day I will have an opportunity to come there and perform an in-person workshop about the simulations. This is what I am really looking for. Again, thank you so much for your excellent organization. Also, another thanks for the previous professor. He had a fantastic speech. I really enjoyed while I'm listening. I really enjoyed. Thank you so much. And again, I am very glad to be here today with the distinguished, excellent Indian Scientific Society. If you allow me, I would like to share my screen. Just a second, please. Okay. Can you see my presentation screen now?
Yes, sir.
Okay, fine. As the Mr. Introducer mentioned, so I'm going to give a brief and useful, hopefully it will be a useful presentation about some specific applications of the Monte Carlo simulation techniques in medical and nuclear sciences. So I'm not going to repeat who is the question, but as the professor said, I am academic staff in the University of Sharjah, United Arab Emirates. Basically, I'm working on the radiation sciences for the medical applications and the nuclear applications as well. Outline of my speech, I'm going to start with introducing the Monte Carlo method. In particular, I'm going to speak about the MCMP-X code, which is the extended version of the MCMP. The technical details, of course, the basic regulations and the hierarchical flow of the Monte Carlo simulations. In the last 2 points, I'm going to discuss about our experiences, actually my experiences and our group's experiences on the Monte Carlo simulation. So at the end, I will come with a summary that this summary might open a different perspective for the researchers that available here and the YouTube now. They are watching broadcasting through the YouTube as well. Yes, I'm gonna start with the Monte Carlo simulations. Monte Carlo simulations actually, they are named after the gambling hotspot in the Monaco. So that's why I put the view of the Monaco here. As we know very well, the Monaco is close to the French. It's like an independent country, and they are. This city is famous with its casinos. So the gambling, Monaco casinos, and the Monte Carlo simulations. In fact, there is no clear link within those terms, but in the principle, we have a strong reasons, we have strong justifications for these abbreviations, that why we are calling as a Monte Carlo simulations. The technique actually was first developed by the Stanislav Ulam. He was a mathematician who really worked on the Manhattan project. Monte Carlo methods, or in other words, the Monte Carlo simulations, are a broad class of the computational algorithms that perform the repeated random sampling to obtain a sort of numerical results and the predictions as well, the considering these numerical outcomes. So basically the underlying concept to use this randomness to solve the problems that might be deterministic in principle. So most of the Monte Carlo simulation methods, they are often used in a physical and the mathematical problems. Last but not least, there are sort of applications in the finance, in the economical models, especially for the institutions on the governments, that they might predict the coming years, the economical outcomes, the expectations, and so on. in particular, I'm talking about the physics applications. So mainly three problem classes, such as optimization, numerical integration, and generating the draws from a probability distribution. Those are our main three classifications that we are considering in the physics application. So in the physics related problems, which is sort of like a material science or chemistry or nuclear energy applications, so we are also able to implement many of the different Monte Carlo methods or the problem solving ways into those ongoing processes. Of course, there are a lot to discuss about the Monte Carlo simulations, but I know that my time is limited, so I just want to jump into some specific definitions, such as the concept of the code. So, of course, I have another experience with the GEANT4 Monte Carlo simulations code. I have a brief experience with the EGS, which is distributed by the Canada governmental institution. But now it is almost 15 years that I've been working with the MCMP, which is the official Monte Carlo tool of the Los Alamos laboratory and distributed by the Stanford from United States of America. And the MCMP code is very specific, very particular, very sophisticated code, as same as other Monte Carlo codes. The MCMP is also provides us different type of opportunities in the case that we can incorporate those solutions into the ongoing problems in the physics. This is like a general purpose code. It has a continuous energy flow, generalized geometry. Of course, we have different ways of to define the geometry of the total setups. It also changes from one to another. It really depends on your realistic setup. I mean, in one hand, you might define a lab where there are like hundreds of the equipments inside. But in other cases, you might define a simple setup where there are like 3-4 tools. For example, a typical gamma ray transmission geometry. In our input files, we are able to define approximately 50,000 lines as our source coding, which is really good. I mean, the number of the 50,000, it's a huge number considering the concept of an ordinary input file. The 50,000, the number of the 50,000 is a huge. So this is another advantage of the MCMP. So it basically solves the particle transport problems. I mean, you may consider the steps of the Monte Carlo simulations in two ways. The first one is the engineering side of the simulation, where you have to define, where you must to define the geometry, the material structure inside, and their locations in the mother volume. The second part of the Monte Carlo simulations is to define your expectations. I mean, of course, since we are incorporating these solutions into the nuclear physics problems or any problems related with the nuclear sciences, we have to define our expectations in a physical way. So, for example, the expected outcomes as a data, either it's like a gamma flux or deposited energy in the air, or the gamma flux on a surface, on a ring, and so on. I will explain them further in the coming slides. But MCMP is also enable us to perform the different type of the transportations. For example, only neutron, only photon, only electron, or coupled transportations, that in a one simulation you might observe three different data from the observation or tracking of the neutron, the photon, as well as electrons. So this is another opportunity that MCMP provides us. Yes, the critical calculations is the main focus of the MCMP simulations, where we need to observe very critical values, especially in the medical physics, especially in the tumor and the treatment issues through the radiation. So as you know, 1 micrometer has a meaning in the treatment planning or the treatment procedure. So fortunately, MCMP is a code that updated, upgraded, and it has daily advances through their source institution. And recently they announced the MCMP6, which is the latest version of the MCMP. So what I mean, the code is not a constant structure, but it has yearly, daily even upgrades, updates through their source institution. Of course, as same as sorry, there is an okay. As same as all other physics progress when it comes to simulation, MCMP has also its own specific unit expression. So the lengths in the input file, we should define them as a centimeter, or if you define, the distance between the source and the detector as a 10, so MCMP will recognize it as a 10 centimeter. So the energy value is MeV. So if you define a source energy value as a 1, yeah, just a digit 1, so MCMP will consider it as a 1 MeV. And that's why we have to be careful, especially in the input definition. We have to be careful if the data is given us in the key AV, so we should perform the required conversations from key AV to MeV. The time, mass density, atomic density, and the cross sections as well. Those are some units that they have their own default units in the code. I want to go through the input structure, which is the most important part of any Monte Carlo simulation. Actually, 99% of the Monte Carlo simulations, they have a standard approach where you need to define the geometry, where you need to define the material descriptions. Especially here, the meaning of descriptions is the elemental compositions of the materials that you are defining in your input file. Of course, the locations and the characteristic of the source and type of the answers, or in short, we are calling as a tallies. The tallies, just keep in mind, it's a sort of way that we are receiving the outcomes. I mean, in the case, if you define a sodium, the sodium iodine detector, so obviously the interactions inside the crystal, and as an outcome of this interaction, the produced signals are important for us. So in the case, if you define the proper tallies into this crystal, so the code will give you an outcome as same as the realistic detector. So I will give some examples actually at the end of my slide. But anyway, this is a brief screenshot for you. The cell cards, here the cell, you can see, by the way, this is a typical gamma ray setup. Very, very simple, by the way. This is a very, very simple geometry that we used in our many publications, because the gamma ray transmission itself, it's a simple setup. So the reflection in the MCMP, of course, it will be also a simple structure. But anyway, here we define a source. You can see the number 4, you can see in the red area, they are cells. And the boundaries, here we defined 5, 4, here you can see 5. Those are the surfaces. So the surfaces are the boundaries around the cell structures. So which means that, by the way, these boundaries, the surfaces, they are visual. In case we don't need to define any specific material definition for these surfaces, but those are visual boundaries that we are using only to form a proper cell. Of course, considering the X, Y, Z axis. And the surface and the data cards, it also defines the sources, materials, material descriptions, tallies, and the other information needed for the problem solving. Here, the meaning of other information, let me give you an example. If you use a point isotropic source, so the distribution of the gamma will be in an isotropic way, but not always all the gamma ray sources in the isotropic form. So you might define an X-ray source where there will be like the cone beam distribution. So in this case, you have to go above and beyond, and you have to specify your source distribution in an advanced way. That yes, I have this type of gamma ray distribution or X-ray distribution. This is the angle, the starting angle. This is the flow of the beam line, and so on. Direction even, right? I mean, there is a difference between 0, 0, 1 and 0, 1, 0. I mean, here in this case, considering the X, Y, Z, we need to define even the direction of the beam line. So 3 of them are important. I can't say that one is more important than another. I'm talking about the cell, surface, and the data cards. I can't say this is the most important one. 3 of them, I mean, each of them has the equivalent importance in the input file, because any type of the mistake, although you write like thousands of the lines in your input, if you have any type of mistake in the one line, doesn't matter it is where, but the program will give you an error, and you will be unable to run your simulation. This is a typical input file. As you can see, here we have the cell cards, here we have the surfaces, and we have the data cards here. From 1 to 19, there are different type of the surfaces that we use them as the boundaries for the cells. The first one is the cell cards. As you can see here, we have 0, 1, 2, 3, 4. The first column is the identifier of the cells. The second one is the defined material environment. For example, if I see the number 1 here, just next to the 3, so which means that the number 3, I mean the 3 numbered cell consists from material 1. So here I need to go down and I need to check what is the material 1. So the material 1 is a material has the atomic number of 13, right? And the 100% of the material 1 or in the cell 1 is filled with the M1, which is material 1. The number 0, it defines the meaning of the vacuum. I mean, if you define the number 0 in a cell, which means there is no material environment. So you may consider it as a vacuumed environment. So there is nothing. So which means that the gamma rays or the neutrons or the electrons will not interact with any particle in those cells where there is a 0 environment. So the material 3, material 4, you can see just in the data card, I defined M2, M3, M4, and those are the compositions. Of course, the one here next to the M1 it defines the concept of the material, either it is 100% or 50-50. So in this case, if it's a complex material, I need to define the percentage, right? So for example, the almost 60% of the material 2 is consist from a material which has a atomic number 12, and almost 40% of the material, I'm talking about the material 2, is formed from a material that has atomic number as 16. So, etc. You may think the same way for the M3 and M4. Another view for you, you can see different colors. Each color represents different cells. Each black lines represents another surface. So the cells are the environments that located in every surfaces. I've been talking about the tallies. Yes, in MCMP we have a special definition for the tallies that we are abbreviating them with the F. So which means F1, F2, F4 till F8. For example, let me give you some brief description. So in the case, if you define the F6 tally into a cell environment, so at the end of the simulation, the code will provide you the energy deposition average over a cell. So instead of a spectrum, instead of a spectra, or instead of a pulse height distribution, you will observe a certain amount of the deposited energy. But in the case, if you are working with a detection system or gamma ray spectroscopy system in your simulation, perhaps you might need to define the F8 tally, which will provide you the energy distribution of the pulses created in a detector. Yeah, at the end, the code will provide you a huge data once you draw it in the origin or in the Excel program. So the program will provide you a regular pulse height distribution. So in conclusion, there is no only one way to observe a data at the end of the simulation. It's totally up to your expectations. It's totally up to your expectations that what you are looking for. Why the Monte Carlo simulations are important for us, especially in the radiation side. This is very important point that I would like to strongly emphasize, because the code is flexible, reliable, and trustable. So all of the data that we are using as a cross-section data, or the physics libraries, or the data cards in the code, they initially observed from some experimental studies. That's why I told you that each Monte Carlo simulation has its own origin country and accordingly own origin labs. For example, I don't know whether you heard about the Giant 4, but all of the data of the Giant 4 code comes from the CERN Accelerator Center in the Switzerland. And for the MCMP, it comes from the Stanford lab, Los Alamos lab, Oak Ridge labs. Yeah, they are all established in the US. It is safe. At least you are performing a simulation in your computer environment. So there is no realistic radiation that will harm you. Of course, the Monte Carlo simulation is the initial part of the experimental studies, or it's only the one way where there is difficulties, or it is impossible to perform any experimental studies. Let me give you an example. In the cancer studies, in the radiation delivering studies for the cancer patients, there is no way to define 1 micrometer dosimeter inside of the tumor, right? Right. So only the one way that we can observe the expected outcomes through the Monte Carlo simulations, because there is no way, physically, there is no way to observe the micrometer scale dose distribution around the tumor. In the case, assume that you have an external Linux source. Here we have a tumor. In the case, if you could deliver this external X-ray to the tumor, so our expectation to see the distribution of the dose, the given dose in the tumor. But physically, it's impossible. Physically, especially around the tumor. Some of the tumors are like 2 millimeters, 1 millimeter, even less. So there is no physical way. So instead, what we should do, we should define some micrometer scale dosimeters around the tumor, and we should detect it, right? So I hope my point is clear in this case. So in conclusion, Monte Carlo is a strong tool for the experimental studies prior to their application, or some of the studies that to conduct an experimental study is difficult, either difficult or impossible. Trends in gamma ray shielding studies. Actually, I am a nuclear physicist who works in the medical and the nuclear applications, but I found a good era in the gamma ray shielding studies for years, especially for the glassy materials. The year was 2003. European Union has published a guideline. The name was Restriction of Hazardous Substances Directive. So they strongly encouraged the researchers in terms of finding some different alternative for the lead and the concrete. Those are, as you know, those are the classical and conventional gamma shields. But they strongly encourage the researchers go ahead and investigate different type of the materials and define and try to find an alternative that the scientific community might utilize them in the gamma ray protection applications, either in the medical fields or in the industrial fields. So the year of 2003 was a milestone for the researchers, because they came across sort of different materials. Actually, those materials are very familiar for us, but to use them in the shielding applications, it began by 2003. For example, glasses, nanocomposites, alloys, and different type of polymer compounds. Of course, since that time, we received different ideas, different structures, different challenge, different incorporations of different oxides into the different structures, and so on. So people, they have tried. They have tried to find a best solution for the gamma ray protection aims, because among those materials, the glasses has a different importance for us. They are transparent, they are durable, they have distinguished material properties, and so on. So that's why we strongly motivated on the glasses for the shielding applications. Some of our publications, of course, it's very brief. I just wanted to show. Here you can see some of our Indian colleagues. Some of them, they are here also. Dr. Gaigwat, thanks to him, and the Majot Gaigwat, another colleague, we could publish some papers with them in the years. Another novel experiments we performed, we conduct through the MCMP. Fortunately, I was the first researcher in the literature who incorporated the nanoparticle definition into a concrete and assessed the shielding efficiency. Yes, we were expecting to see an increment in the shielding efficiency before the simulation, thanks to the meaning of mean free path, right? Because every increment in the nanoparticle amount in the structure will decrease the mean free path as well. But it was our expectation. But fortunately, the literature, the scientific community were thinking in the same way with us, but I could utilize this simulation, or I could define a simple specimen, and I could define the nanoparticles into the concrete sample. So I observed the similar increments between the ordinary concrete and the nano-scaled concrete. And this was the first publication in the literature. Within 4 or 5 years, it got a serious number of the citations. And another important point, that many of the researchers, they tried to reply, they tried to perform the same studies in the literature. So which was a motivational point for me. So we published another one about the nanoparticles. So we published in a different concrete structures. Of course, gamma ray simulation is just one of my application area. As I told you, I am basically a medical scientist who utilize the nuclear applications into the medical experiences. So in the years, we could design some chest structures, as you can see, the lungs, cervical spine, the breast, heart tissue, and so on. We could perform different type of the medical simulation studies. They were really novel studies at that time. This is very novel study. It has been published last week, only last week. And what we did, going beyond the typical detector structures, we designed a plastic scintillator detector. As you can see, up to page, you can see the physical detectors. So what I did, I modeled this detector in MCMP. You can see this is the modeled one by me, and this is the realistic detector, which is available in the Istanbul University, Turkey. So fortunately, we performed some of the studies that they didn't perform through the physical detector, and recently it's published in a journal. Last but not least, I performed a huge human phantom-based study that we checked the efficiency of the eye and the breast shielding during the cervical spine radiography. This was also a novel investigation in the literature. You can see the screenshots directly obtained from the MCMP. This is the realistic human phantom. The abbreviation is MIRD. Of course, I modified it. I modified extremely. I redefined some of the tissues and the organs definitions. I redefined the shielding materials here, as you can see. Also the pink ones, as you can see, just front of the eye and just front of the breast. This was the motivation of our paper. One another novel investigations. This is also fresh, as you can see. It has been published almost 4 days ago. I deliberately put this slide here just to give you a motivational point. As you know, the term of container is very important for us in the nuclear sciences, especially in the medical fields, especially in the nuclear medicine. In terms of delivering the source from one to another point, we need to use the proper containers. Another point is in the nuclear bases, nuclear energy plants, the waste disposal and other issues should be done through the containers. So in this case, we compared the efficiency of heavy metal oxide glasses as a container in the comparison with the concrete samples, because this type of concrete is very traditional for the applications as container. So what I did, this was also a novel study. I'm really happy. So hopefully we will continue on this project. So I defined a typical container. Here you can see there is a source and surrounded by the heavy metal oxide glasses. And in the second stage of the simulation, I designed the container as a concrete. So what I did, I measured the absorbed energy dose around the container. Even I measured the individual dose attenuation values inside the material, millimeter by millimeter, as a dose decrement by the distance. So we performed a huge simulation study, and fortunately we published it recently. In conclusion, material design, organ tissue modeling, medical physics applications, nuclear medicine, shielding studies, and nanoparticle design, those are some of my experiences in the simulation. So usually it's enough for me to know the scenario. It's enough for me to know the expectations that I can design any type of the simulation, any type of the geometry, and so on. Thank you so much. I really appreciate your participation, and your questions are more than welcome. If there is a question, I try to keep it short little bit, but again, Dr. Ram, is he with us? So I am expecting an invitation from you to India to perform a workshop for the Indian PhD and master students in the coming years. I will be very glad to come there and to support Indian Scientific Society.
No, sir, sure. We will wait. Sure, sir.
Thank you so much.
Thank you so much, sir.
Appreciate
Any questions from participants? The session is now open for the question answer. Please, any questions? I think there are no questions, sir.
Thank you so much. All my profiles and the contact details are available in the web page or in the research gate. So the colleagues, please do not hesitate to contact with me in terms of any question, any collaboration, any common idea, common sense that we can share each other.
Okay,
Thank you
sir.
so
Okay.
much,
Thank you
and
so
all the
much
best for you.
Informative session. Thank you so much, sir.
All the
Thank you.
best. Bye-bye.
Thank you. Thank you, sir. Now the sessions of day 1 are over here. We will meet tomorrow at sharp 11 a.m. So the feedback link for the same is provided tomorrow itself. So we will end here, stop here. Thank you so much. Yes, sir.
Thank you for everyone. Feedback link will be shared with you tomorrow. So yes, sir. Okay. Thank you for everyone. So we will end of this session. Thank you. Thank you, everyone.
Thank you, sir. Dr. Karthik sir, we will provide you link of feedback tomorrow. Okay. Thank you everyone.